Okay, so for your warm-up, I want you to go ahead and try to attempt these first three problems. You can use a calculator if needed, but try your best. Okay, so starting with number one. You might not even have needed a calculator for number one. You might have been able to do this in your head, but you read this as 3 to the x power equals 9. So if you think about it, what can I put in there for x? What power can I take 3 to? That would yield me an answer of 9. And that's just going to be the second power. So x would be 2. 3 squared is 9. Okay? Same thing with number 2. Maybe in your head you're able to do this, maybe not. Either way, if you start typing in 4 to the powers, so 4 to the first would give you 4, 4 squared would give you 16. If you typed in 4 to the third, it would give you 64. So x equals 3 on this one. Okay? And then we get to this problem of number 3. There's probably no way you could have done this one in your head. But if you use the guess and check method and you just kept typing in numbers, taking 3 to certain powers, you might have got this one. Okay? But what we're going to find out is there's actually an easier way, okay? Guess and check is not the way we have to solve problems that look like this. So instead, we're going to use what we call logarithms. Kind of a weird word. We'll shorten it, we'll abbreviate it, we'll call them logs most of the time, okay? But how these are used is to help us solve problems that have exponents that are variables. So anytime you're dealing with exponents that have variables such as x in them, you have to use logs. Okay, so we'll show you how this works. So first we gotta talk about how to just write this in what we call logarithmic form, log form. Okay, so if I had an equation that looked like this, we must identify what the base and the power is. Okay, so if we're looking at this equation, okay, we can automatically see the power, the exponent is going to be x, okay? And remember that the base, so whatever has the power on it, that's what the base is, okay? So in this case, it's 5. The 5 has the power on it, so that's why it's the base, okay? So what's going to happen is the base will come over, and it's going to be the base of your log, okay? So the base is going to stay the base. And the exponent is going to be what the log is equal to, okay? So for instance here, we're going to write log. Like I said, we're going to abbreviate. We don't want to write logarithm out every time. Anytime we have a base, it's going to be written low right next to the word log. Okay, so log of 5 is what they're, log base 5 is what this is saying, okay, of 25 equals the exponent of x, okay, so that is how this works. Whatever's on the opposite side of the equal sign in the equation is going to now be what you're taking the log of, okay. The base is always going to stay the base, and then the power is always going to be now on the other side of the equal sign. Okay, we're going to practice this. So here we go. I'm going to do number 1 with you. So if I were to write this as, or in log form, I would start by writing log. My base is always my base, so that's going to be 14. I'm taking log base 14 of whatever's on the opposite side of the equal sign, so of 196. And I'm setting it equal to the exponent of 2. So this says log base 14 of 196 equals 2. Okay? Same thing with example 2. I'll do this one with you as well. Log base 3 of 81 equals 4. I want you to pause the video right here, and I want you to do the next 4. Take about 1-2 minutes. That's all it should take you. Okay, example 3, you should have put log base 12 of 12 equals 1. Example 4, log base 36 of 6 equals 1/2. Example 5, log base 2 of 1/8 equals -3. And lastly, log base 8 of 16 equals 4/3. Okay, Hopefully you got those correct. Now we're going to move on. We're going to go the opposite direction. So taking something that is in log form and writing it in exponential form. Okay, so it's just going the opposite direction. So we know that the base is going to stay the base. We'll call it b. Okay, this time, whatever's on the opposite side of the equal sign is now going to be the power, and we're setting it equal to what we're taking the log of, so a in this case. Okay, I'll do example 1 for you. This would be 3 to the second power equals 9, which makes sense. We know that's true. Okay, pause right here, take about a minute. I want you to do 2, 3, and 4. Okay, number 2 should have been 6 cubed equals 216. Number 3, 7 to the 0 equals 1. And lastly, number 4, 4 to the negative 2 power equals 1 over 16. Okay, here we go. Common base logs. So, a logarithm with a base 10 is what we call a common logarithm. And this is actually the way that our calculator has logarithms. So anytime you type, like for instance, if you go on your calculator, if you're using one of mine, awesome. If you need to pause the video so everybody can grab one real quick. If you don't have one, please do so. Okay, so if you have a calculator in front of you, you're looking for the LOG button. If you're using one of mine, it's in the top left, right underneath the second button. It's one down. It says LOG. Okay, so anytime that you type in a log, it's going to automatically give a base of 10, and it's going to not write the base. It's not going to show you a little tiny 10 underneath that word log, such as it does right here. Okay, we just have to know that anytime that you don't see a base written, it is 10. Okay, and again, most calculators are going to automatically do a base of 10. So we are actually going to put that calculator aside though, even though we will use them. We do need to know how to do these without a calculator. Okay, so example 1 here, this wants me to evaluate this log. So I don't know what this equals. I can make it equal any variable that I want. Okay, and to evaluate this, I want to keep my base, take it to that exponent, and set it equal to what I'm taking the log of. Okay, and I should be able to do this without a calculator. And in fact, your first quiz next class is going to be a no calculator quiz. Okay, your test, everything else after that, you can use a calculator, but I do want you to just know how to do these. Use your mental math to the best of your ability. Okay, so 7 to what power is going to give me 49? It's going to be 7 squared. Okay, if you need to go write out your powers of 7, 7 to the first, 7 to the second, do that. Okay, and even 7 to the 0, you know, anything to the 0 power is 1. Do that if that helps you. Okay, if this isn't something you can picture in your head. Okay, next one is example 2. Let's try this one out. So it'd be 3 to the x equals 27. So again, no calculator here. 3 to the 0 is 1. 3 to the first is 3. 3 squared is 9. And 3 to the third is, got it, 27. Okay. None of the ones on your quiz are going to be any bigger than what these are. So these should be some stuff you can do in your head. Okay. Next 4 are a little bit more challenging, but I want you to work with your group and just attempt these. Okay. Again, remember, for example 3 right here, what is the base if it's not written? We just talked about this. If it's not written, it is 10. Okay, so go ahead and try those. Take about 1.5 minutes, 2 minutes tops, okay? And try 3, 4, 5, and 6 with your table. Okay, so for example 3, 10 to what power is going to give me 100? Okay, if you think about it, it's not 10 to the 10th. We know 10 times 10 is 100, but 10 to what power is 100? And that's going to be the second power. 10 squared is 100. Okay, example 4 is going to be 12 to what power equals 1. Well, we know a rule here. Anything to what power equals 1? 0. Need to know that rule. So write that over to the side if you need to. anything to the 0 power equals 1. Exclamation point, because it's important. Okay, cool. Number 5. 2 to what power equals 64? This would probably be a good one to go write out your powers of 2 to the side. Okay, and you should have got x to the 6. Or sorry, x equals 6. 2 to the 6 power equals 64. Okay, and then lastly, number 6. 9 to what power equals 1 over 81? This might have stumped you. Okay, so we got to think about fractions in this sense. I know that they're our favorite thing ever. A little sarcasm there. Okay, if we think about just the number 81 in general, okay, 9 to what power would yield me 81? Hopefully you're thinking 9 squared, okay, because 9 times 9 is 81. But in order for this to be a fraction, okay, if I had 9 squared, it would just be 81 as a whole. But that's not what I'm looking for. I'm looking for 1 over 81 as my answer, okay? So what we want to do is we just want to make that 2, that square, we want to make it negative. Because what that would do is we know we can't have negatives up top, right? That would make this 1 over 9 squared, which would then yield me 1 over 81. Okay, so the answer to this should have been x equals negative 2, not positive 2, negative 2. Okay, cool. All right, change of base formula. So what happens when I give you one that you cannot do without a calculator? You can't do it in your head, okay? This is when we're going to use the change of base formula or theorem. And this is when our calculator comes in very, very handy. So make sure you have that around you, okay? So what the change of base formula is saying is I can take any logarithm and I can break it apart, okay? Meaning that I'm going to take the log of the a value, so the big number, divided by the log of the base, the little number. Okay? And I can do this in my calculator. So the reason I can is that it doesn't matter what these bases are. If I split these apart, I can divide them and get the right answer. So since we're using a calculator, we're just going to automatically assume that the base is going to be 10. Okay, that's what we're always going to use because our calculator does bases of 10. It doesn't do anything else. Okay, so we'll show you how to use this in this example. Okay, so 5 to what power equals 30? That's not something you can do in your head. Okay, because we know 5 squared is 25, right? And then 5 cubed would be 125. So yeah, we know it's going to be between 2 and 3, but we don't know exactly what it's going to be. Okay, so this is one that we would split up. So this is log base 5 of 30, right? And we don't know what it is. So in our calculator, we would type log 30 divided by log 5. Okay, so I want you to grab that calculator and I want you to do that with me. Log 30, close the parenthesis though. Gotta close it. It's gonna automatically put parentheses around your a value, which is good, okay, but you got to make sure you close it. So log 30, close parenthesis, divided by, type log again, of 5, and hit enter. And you should get 2.11, and then it's a big long decimal. So 2.1 or 2.11, whatever you round to, okay? So again, we knew it was going to be between 2 and 3, but there's no way I could have estimated or known exactly what that would have been without using my calculator, okay? And your calculator will also work for ones like this, even though we can do them in our head. So if I broke, for instance, example 5 apart, and I did log of 64 divided by log of 2, you should get 6. So try that one too. Okay, if you need to pause the video, if anybody's stuck, okay, if anybody's stuck, raise your hand, let's pause the video, have a neighbor help you out here. Okay. All right. I want you guys to try these with your calculator. Okay, examples 1 through 4. We'll pause the video right here. Take about 1.5 minutes, 2 minutes. It shouldn't take you any longer. Okay, so in your calculator, you should have done log 64 divided by log 16. And you're going to get 3/2, or your calculator might have given you 1.5. We'll take either answer. Okay, the next one is going to be log of 32 divided by log 8. And your calculator is going to give you either 5/3 or it's going to tell you 1.6 repeating. I'll take either answer. I don't care. Okay. Then we get to example 3. So that's log 54 divided by log 2. And that should have given you, I didn't write that one down, 5.75. Okay, and then lastly, log of 1/36. Type it in a fraction, put it in parentheses like always. Gotta close those parentheses. So log of 1/36 divided by log 6 is going to give me -2. Okay, so those should be your answers. Ask somebody around you that got them right if you're still stumped. Okay, and now we're moving on. So next thing is natural logs, kind of like regular logs, but they are healthier. Just kidding. That was a cheesy math joke. Okay, so we've talked about common logs. So those are the ones that have a base of 10, and it's not usually written. Okay, and these are the ones that our calculator will do for us. Okay, so just type in, what is log base 10? What is log 10? So in your calculator, just type log 10, hit enter. It should give you a 1. Okay, then type log 100, hit enter. It should give you a 2. You should be noticing a pattern. You can probably guess that log 1000 is going to give you 3, and it does. Okay, so that's the pattern with common logs. We also have natural logs, okay, which are going to be very, very similar, okay, in that they don't have a base that's written. It's just automatically assumed that we know it. So anytime you see a log with no base written, automatically we know the base is 10, okay? So anytime that we see a natural log, instead of log to the e base, which is going to be what that base is, we just go ahead and write ln for natural log. Why is it not nl? I have no idea, okay? But ln is our natural logs. And again, we don't need to write the little e right here for the base. We're just going to automatically know that e is the base. Okay, hopefully you remember from Algebra 1, I think we've talked about it a little bit in here too. E is a base, so if you go on your calculator, you should see a natural log button right under the log button. On my calculators, it just says ln, and then above it, you'll see a little e to the x. Okay, so hopefully you see that. E is its own base. It's kind of like pi, so it just kind of it's its own like random repeating decimal. Okay, so let's go ahead and try that. I want you to hit second, hit the natural log button so you get the e with the caret that pops up, and then just do e to the first power, hit enter. And you should get like 2.7182. It just keeps on going. So it's just like pi. It's just a never-ending number. Okay, so that's what the base of natural logs is. It's just that number. Okay, so we don't want to write out 2.71 blah, blah, blah every single time. So that's why we just abbreviate it as E, okay? So natural logs have a base of E. We don't write it. We literally just type ln. Our calculator knows what we mean, okay? So for instance here, log base E of 20 is the same thing as natural log of 20. The same thing. We don't need to write the E, okay? So E to what power equals 40? Well, normally we would write log, we would put our base, right, of that number set equal to the exponent. So that's how we'd get this. But we know log E is just natural log. So that's just the same thing as natural log of 40 equals x. Okay? We are going to practice this. So again, I kind of rambled on the last slide. But E is an irrational number. An irrational number, and it has an approximate value of 2.718. It keeps on going, okay? And it often occurs as a base in exponential and logarithmic functions that describe real-world scenarios. So word problems, our favorite thing ever. A little more sarcasm there, okay? Let's go ahead. I don't really care about this box. We'll just put a little X through it. But logarithmic functions with base e are called natural logs. Okay, and again, for instance, natural log of 3, that's an example. And again, we abbreviate with ln. Okay, so we're going to go back and forth between each forms. I'm going to do 1 and 4 with you right now, and then you are going to do the rest, my friend. So, real quick, with number 1, again, log base e, okay, but we'll just write ln because we know it's the same thing. Ln of 24 equals x. That's what I want you to write there. And I'm not going to solve that out. If I did, though, I'd just type natural log of 24, hit enter, and I should get 3.178, okay? So if you want to try that real quick, you can. But this didn't ask me to solve it. It just asked me to write it in the opposite form. So that's what we're going to do here, okay? And then same thing with number 4, but go in the opposite direction. So we know anytime we see natural log, that's base e of 58. That's my exponent. Or log e to the 58th equals x. So that's how I would write that in the opposite direction. Okay? So take about 1.5, 2 minutes, real quick. 2, 3, 5, and 6. Don't have to solve them, just have to give me the other form. All right, number 2, should have put natural log of x equals 9. Number 3, natural log of 72 equals x plus 5. Number 5, e to the x equals 6. And number 6, e to the 32 equals x minus 9. Okay, we'll get into the fun part of solving these later on. But for now, I just really need you to be able to go back and forth between the two forms. Okay, so check Canvas for your homework. And that is all I got for you guys today. Thanks.